thing sort of in its time and its place. But today, you guys are going to end up with a really nice, in just a few minutes, quite frankly, a really nice method. Now, honestly, the half sheet that I gave you, I should have told you, I see some of you taking out your notes. The half sheet that I gave you really is the notes. If you want to copy it somewhere else, you can. But a lot of kids just use the half sheet and maybe staple it or tape it or just put it in a pocket that's in your notebook. But make sure no matter where you're writing things down that you walk out of here, well, and even in the next couple minutes, that you realize, oh my gosh, there's a really cool connection between a system and a matrix. Now remember, a system is one of those deals where you have a couple equations and you're trying to solve them for x and y, or maybe x, y, and z. Obviously, if you look at the half sheet of paper, you can see there's systems all over it. So where do matrices come in? Well, let us find out. Like I said, you've come to the right place. Before we actually get a matrix involved, let's solve this system. If we're going to make a connection, then it's usually a good idea to go back and remember what it is that we're doing. So this is a nice little system. I'm sure that you can solve this pretty much in your sleep, but we'll just kind of run this together. I feel like I want to add these equations together, but before we can do that, we obviously need something that's negative or opposite. It's probably going to be really easy just to throw a negative sign at one of the equations. Do you agree? It makes it pretty easy to cancel the y's. So nothing real new happening here, but we do want to realize that you end up with a solution. You end up with x equaling -7. And then my guess would be that most students would feel an overwhelming desire to plug this -7 back into one of the equations. You could plug it back into the original equation. Notice that I did cross off all the negatives because those negatives kind of made that equation tricky. But anyway, plug in -7. All right, well, I might have been usurped by something more interesting, but if I can back to this, are we finding that y equals 15? Just plug in -7 and get the job done. So you find out that y equals 15. Now, everybody should say that's pretty easy. And yes, it is. But what if we had a complicated system? Okay, well, it turns out that a matrix can actually make the problem easier. A matrix can make a system easier, even though this one, as we agree, probably can't get much easier. But let me show you something about what is true if we, as I say, if we think about a matrix from these numbers. Now, there's no reason I can't do this. There's no reason I can't think about taking that part of the equation and interpreting it as a matrix, as a 2x2 matrix, if you consider with me what's called the coefficients. Now, the coefficients would be the numbers in front of the variables. So just so you understand what I'm saying, there's like a 1 and a 1, and well, there's already a 2 in front of this one, and of course there's a 1 right here. Well, those coefficients make up a matrix, and so we're going to go ahead and actually sort of pull that off to the side here, and we're going to put in those numbers 1, 1, 2, and 1. And we're going to call that matrix A. You'll find out why, but it's very common because that's the first matrix we made, just to let it be A. Now, if you look over here at this system, there's some other stuff in it. Like there are variables. There's x and y. And the funny thing is that they're shared by both equations. Well, we can take those variables x and y, and we can also let them become part of just a matrix. And we don't have to write them twice. You'll find out that we only really have to think of it once. So I take the variables x and y, and I put them into a column matrix. Now, we're going to call that matrix X. just generically that we'll call it matrix X because it contains the variables. There is one more thing over here that you can't disagree hasn't been thought of yet, and of course it's what we call the constants. The constants are the numbers that stand alone. They're the numbers that are not with the variables. And so see how we can turn them into a matrix? Well, we're going to go over here and we're going to say that everything that we just wrote is going to equal those constants. It's going to equal 8 and 1. And we're going to call 8 and 1 matrix B. Now, it's okay if maybe you're like, you can do this? I wouldn't have done this, but I'm telling you that you can. And when you do, you end up with a really simple equation. It's an equation that says that A times X is equal to B. It's a very simple equation that says A times X is equal to B. And what I want you to realize is that if we solve that equation for X, then we will have in fact found the same X and Y. In other words, we'll have found the solution to that system. How do you solve this equation for X? Well, unfortunately, you can't divide by A because we never learned something called matrix division. And the reason we never learned that is because you don't need matrix division. You just need the inverse. You see, the inverse will also cancel A. And what you're seeing me do here is the inverse of both sides. Now, we're almost there. It's sort of like the grand finale. But what I want you to realize is right now we have this little statement. It says X equals A inverse times B. Now, that little statement is something that we can do on Desmos. It's something that we can do using a computer that can handle matrices. Why don't you take out your computer? I'll say nicely that you're gonna need Desmos to be able to do everything that remains during this little lesson. Now, do you remember how we looked at this the other day, and have you used it since then? It's desmos.com/matrix. Desmos.com/matrix. It's probably a place that you'll be going a few more times in the next week or so. Just so you kind of get the gist of what's about to happen, everything that we just kind of wrote down, we're now going to tell Desmos to do. So we need to tell it what matrix A would be. Matrix A, remember, it was the coefficients. And so you can do new matrix, and you can tell it that it's going to contain 1, 1, 2, and 1. And don't let me hold you back. We're going to also type in matrix B. Matrix B needs somewhat edited so that it's just a column that will contain 8 and 1. Now, you may not realize it quite yet, but I think you're going to very shortly, that formula, that A inverse times B thing, that is where it's at. That is what we want to do. We want to do A inverse times B. And again, the computer is going to do it for us. Remember how to get A inverse? You still have to click A, but then you can hit this inverse command. And then you can, of course, type B. You don't need to put a times sign. It'll assume that you're doing A inverse times B. And would you look at this? Over here on the right-hand side, we have something that you will grow to like. You will like it a lot. I would assume, as long as you like things that make your life easy. We get -7 and 15. We get the exact same values. Because what's really happened here, folks, is that we just solved that system. Remember that thing we started with at the beginning of the period? We solved that system, using matrices. And so A inverse times B was able to produce the same values. It was able to produce -7 and 15. Now, you can write those numbers down, but eventually, or for now on, what I want you to really do is to interpret what they are. And of course, we know that X is the -7 and Y is the 15. And as you guys think about what just happened here, we end up with the same solutions, but we use matrices to solve it, to make our life easier. Now, there's a formula. I'm trying to call it magic just so it kind of grabs your attention, but it's the big deal today. Do you realize what it is? It's not the last time you'll hear it, but please understand it's very important. It's A inverse times B. A inverse times B. That is the big deal today. It will solve any system using matrices. Now, there's a good chance that all of you are going to catch on here at some point in the next few minutes and kind of be like, I got this. So don't let me hold you back. But I do have two examples that kind of show you some sort of some intricacies, some stuff you got to be careful about. Once you realize this, you're ready to roll. So I hope you look at this system and kind of feel like it's a little bit out of order. It's a little disorganized. And so, yes, when you type this stuff into the matrix feature, it needs to be organized because matrices are organized. So do you feel like this -2x should really be over here? Well, yes, you have to add 2x to the other side and make this equation be a little bit more organized. 2x plus 3y equals 9. Now, if you say, well, what does it mean to be organized? It just means that the variables are in the same order. Most kids will put them in alphabetical order. And it also means that your constants, remember the constants are the numbers that are by themselves, that those are all by themselves on the other side. And once you have the system organized, it's almost too easy. It's almost too easy. It's kind of like you just end up with these two matrices. Now, I did put brackets around those. If that helps you, you can do it. I will say that I do ask you to show at least one step of work. And if we even want to call it work, this would be one step of work where you show matrix A and matrix B. What do you guys think? Is it reasonable to at least show matrix A and B? That's kind of all I'm really asking you to do. Make sure you realize that matrix A is the coefficients and matrix B is just the constants. And then it's on to Desmos. It's on to Desmos. You're allowed to use this. Just be careful. Remember we talked that, you can clear Desmos by hitting the refresh button. You can also type over top. You can type over top of your old matrices, but basically, if you're going to use it, then be careful. But you can type in matrix A and matrix B. Pretty easy. And then please, as a big takeaway, use A inverse times B. That actually is a math formula that is truly a big takeaway from this year. And some of you would have heard about it last year. So you might be saying, yeah, I kind of have seen this, but it's a big deal in math because it can solve a system. As long as you understand that the numbers 3 and 1 are your solutions. And your solutions will always be in the same order that you put your equations in. So assuming you put it in alphabetical order, although you don't have to put it in alphabetical order, but since X came first and Y came second, 3 goes with X and 1 goes with Y. And that's all there is to it. As I said, I don't want to hold you back. If you're looking at this next one, you're kind of like, I want to try this, then try it. If you want to listen, I'm going to be making sure that we're just on the right page. But basically, you just have to organize these equations. you should feel like the first equation's already organized. You don't need to recopy it, although I am. The second equation, you should feel like that the y and z, do you feel like the y and the z just need to swap? Obviously, the negative sign is going to go with the z, but we're just going to swap y and z. And then your last equation, sometimes this is a little mistake that people make. You should feel like that the 3 isn't really a 3. You should feel like that 3 really needs to be a negative 3 as it gets subtracted to the other side. So be careful about that. That's one of the most common mistakes, that people just say 3, but you're going to say negative 3. Okay, obviously this is a bigger system. A few days ago, this would have caused some pain and suffering. You would have had to work really hard. But honestly, right now, we have a matrix that doesn't even blink at how to take these 9 numbers and then take those 3 numbers and very easily calls them matrix A and B. And that's the whole point behind this. The matrix method isn't even going to blink at how to solve for X, Y, and Z. What do you guys think? Is there anything that's happened or that's going to happen? Do you have any questions on how we're taking the numbers and just putting them into a matrix? It's pretty slick. But the whole reason it works is because you are using A inverse times B. I will mention that if you don't use the inverse symbol, it's not going to make a lot of sense. The inverse symbol is actually what's solving the equation. For a couple of you that I can tell are already done, honestly, the problems on the back are the homework, but why not, right? I mean, you're going to get working on them. So the problems on the back make up the homework. Just by the way, the answer to this problem was 3, -3, and 4. And you really should say so. You should say x equals 3. You should say y equals -3. And z equals 4. Now, as I said, why not, right? You're going to get into these 6 problems. Maybe you're even going to finish them. There is a little exit ticket. In about 10 minutes, I'm going to kind of display it. But right now, go ahead and work on these kind of straightforward problems. And then the exit ticket might be something that at that time you'll feel a little bit more ready to try to figure out.